Hello, this is Bufan Song N15169107 for Probability and Statistic Homework 2, Question 2. For Question 2, it asks, there is X1 signal goes into the noisy channel and goes out X2, and for XK goes into noisy channel, there is XK plus 1 goes out. And for the given information, we can see that the probability of x1 equal to 0 is 0.2. The probability of x1 equal to 1 is 0.8. And for all k bigger than 1 and smaller equal to n, the probability of xk plus 1 equal to 0 given xk equal to 0 is 0.6, and the probability of xk plus 1 equal to 1 given xk equal to 0 is 0.4. And for probability xk plus 1 equal to 0 given xk equal to 1 is 0.3. And also for the xk plus 1 equal to 1 given xk equal to 1 is 0.7. So for subproblem A, we need to find the probability of x2 equal to 1. So for the probability of x2 equals to 1, we have two situations. One is that when the x2 is equal to 1, for when x1 is equal to 0, and also x2 is equal to 1 when x1 is equal to 1. So we can write as the probability of x2 equals to 1 given x1 equal to 0 times the probability of x1 equal to 0. And this is one situation. And another situation is the probability of x2 equals to 1 given x1 equals to 1 times the probability of x1 equals to 1. So based on the above information, we can see that x2, this is equal to 0.6 times 0.2 plus 0.7 times 0.8. So the final answer is 0.64. And for subproblem B, it asks about the probability of x3 equals to 1. So just the same process, but a bit complicated than the subproblem A. So the probability of x3 equals to 1 is the probability of x3 equals to 1 given x2 equals to 0 times the probability of x2 equals to 0 plus another situation, x3 equals 1 given x2 equals to 1 times the probability of x2 equals to 1. So for above, we can get that the probability of x2 equals to 1 is 0.64. So the probability of x2 equals to 0 is 1 minus 0.64. It is 0.36. So for this one, it goes to here. So it's 0.4 times 0.36. And for this one, it goes to this. And it is 0.7 times 0.64. So the final answer is 0.592. And for subproblem, find probability of x1 equal to 0 given x3 is equal to 1. And for the probability of x1 equals to 0 given x3 equals to 1, we can rewrite as the probability of x3 equals to 1 given x1 equals to 0 times the probability of x1 equals to 0 and divided by the probability of x3 equals to 1. This is because the conditional probability. And we know that the probability of x3 equals to 1 given x1 equals to 0. So for this 0.6, 0.3, 0.4, 0.7, it is actually a matrix. We can write like a matrix. So for all the probability x3 equals to 1 or either 0, given x1 is either equal to 0 or 1, we can write the answer in the matrix blocks. So by 2 times 2 matrix times 2 times 2 matrix, we have the equation and can get the answer. The final answer, it is 0.48 and 0.52, 0.39 and 0.61. And what we ask about is the probability of x3 equals to 1 and x1 equal to 0. So it is equals to 1, x3 equals to 1, and it is this one. So the probability is 0.52. And we put this probability into that equation here, and we can get the probability of x1 equals to 0 given x3 equals to 1. It is 0.52, which is this one. And the probability of x1 equals to 0 is 0.2, and the probability of x3 equal to 1 is in subproblem B, 0.592. So what we write here is this, and we get roughly 0.176. And for the subproblem D, we need to find when n goes to infinity, we need to find the probability of xn equal to 0. So what we do here is we assume the probability of xn equals to 0 is k. Assume it is k when n goes to infinity. And on the other hand, xn equals to 1 is 1 minus k. So because it goes to n goes to infinity, so it's actually for the probability of xn equal to 0, it is almost equal to xn minus 1 equal to 0. So we can also think that the probability of xn minus 1 equal to 0, it is around k. And also for the probability of xn minus 1 equal to 1, it is around 1 minus k. So what we think about is the probability of xn equal to 0, it is equal to the probability of xn equal to 0 given xn minus 1 equal to 0 times the probability of xn minus 1 equal to 0 plus another situation when the probability of xn minus 1 is equal to 1 times the probability of xn is equal to 0 given xn minus 1 is equal to 0. So for this part, xn equal to 0 given xn minus 1 equal to 0, it is the same as the given information. So it is 0.6. So what we write is 0.6. And this one, as we get, is almost the same as xn equal to 1. So times the k, and plus this is equal to this one, so 0.3. So 0.3 times the probability of xn minus 1 equal to 1. So it is 1 minus k. And for the probability of xn minus 1, it is what we assume is k. So by given this equation, we can get k is equal to 0.3 plus 0.3k, and we get 0.7k is equal to 0.3, so k is equal to 3 divided by 7. So this is question 2. Thank you.